Okay, hi guys. So we'll be now talking on very important concepts, which is gas laws. Okay, so let's define that for an ideal gas. We can say that we have discussed this so many times that PV equals to nRT. Okay, so R we already know it is 0.082 atm liter per mole Kelvin. Okay, or R can be written as 8.314 joule per mole Kelvin, which is nearly can be written as 2 calorie per mole Kelvin. So please remember all these units of R, whether we have discussed it or not in the previous lectures, but from now on it should be thorough for you, thorough in all your minds. Okay, so first law which we'll be discussing is Boyle's law. So Boyle's law states that for a fixed amount of gas at constant temperature, pressure exerted by the gas molecules is inversely proportional to the volume of gas. Okay, so for a fixed amount of gas at constant temperature, pressure exerted by gas molecules is inversely proportional to the volume of gas. Okay, so we can write that at constant NNT, pressure is inversely proportional to the volume, as P will be equal to nRT by V, and nRT would be considered as a constant here, as we have been given that NNT are constant. Okay, so let's discuss or look at the graph of the same. So we have to discuss graph between P and 1 upon V. So it would be nothing but a constant value, which is m or tan theta can be written as nothing but nRT. Okay, so for a different value of n1 nnt, we can have different value of slopes as well. So again, P and 1 upon V can have different value of slopes. Okay, so this is at n1 t1 and this is at n2 t2. Okay, so let's discuss some of, so before, let's discuss some apparatus. So suppose we have some weight here which is exerted on some gas. Okay, so here we can say that as pressure increases, as we put more and more weight on top of it, the volume of the gas will decrease, and this phenomenon is known as compression. And as we lighter down the weight on this, so in a sense we are decreasing the pressure, hence volume will increase, or this will go upwards, this boundary. Okay, so in the above case, we can say that if, so let's suppose n is constant, then we can say that t1 is greater than t2. That's why m1, which is nRT, is higher for, or rather tan theta value is higher for this graph. Okay, and if t is constant, then we can say that, let's suppose if t is constant in the above, so let me write it down near to the graph only. So if t is constant, then we can write that n1 must be higher than N2 because M1 was higher than M2. Okay, so let's discuss the graphs, more graphs on pressure and volume when we have constant temperature. Okay, so when we have constant temperature, we can write that constant temperature and constant number of moles, then we can write that PV equals to nRT, or PV is some constant K. Okay, so as PV is some constant K and V is inversely proportional to P, so the nature of graph would be something like this. And as temperature is constant, we can say that this graph is isothermal. Okay, obviously we also have constant and NT. Okay, so now if we have to draw the graph between, let's say, PV square and V, what would be the graph, or rather how would the graph look like? So we know that PV equals to K, and if you multiply it with V on both the sides, then it becomes PV square is equals to KV, or Y equals to MX form is achieved, hence it would be a straight line. Okay, what would be the nature of graph for, let's say, we have P upon V versus 1 upon V square. So we again know PV equals to K, so let's divide both the sides by V square, so it would be again 1 upon V, hence it's again Y equals to M, X is 1 upon V, so this implies Y equals to MX again, so again it would be a straight line. Okay, what would be the nature of graph at constant temperature and number of moles between P upon V and let's say 1 upon V. Okay, so what would be the nature of this graph? So again PV equals to constant, divide on both the sides by V square, rather this was PV upon V square, so V and V got cancelled, so Y would be equals to P upon V. Okay, so again in this graph, when we divide both the sides by V square, we will be getting 1 upon V would be equal to K upon V times 1 upon V, or we can directly write K multiplied with 1 upon V square, this is Y, and which is equal to M times 1 upon V is X, Y equals to MX square, which would be a parabola. Okay, next we'll be discussing a graph between PV and let's say P. So we know PV equals to constant. Suppose if we multiply both the sides with, rather we know that PV is constant, right? So if PV is constant, this implies y-axis is constant. So if y-axis is constant, we can directly have this graph where this is nothing but nRT. Okay, next let's look at what will happen if we have on y-axis we have, let's say, PV, and on x-axis we have V. So again PV is constant, so we have y equals to some constant value, doesn't depend on the value of V, hence again it would be the same graph with the intercept as nRT. Okay, but if we now have two different temperatures here, let's say T1 and T2, such that T2 is greater than T1, and again we have the graph between PV and P. So at temperature T1 this would be the nature of the graph, and this would be the nature of graph at T2. So this is nRT1 and this is nRT2. As T1 is greater than T2 is greater than T1, this intercept would be greater than thus T1 intercept. Okay, we can also have some mathematical relation if you guys are interested in looking in it. So this is a bonus. So if PV equals to K, then if we take log on both the sides, then log of ln of P plus ln of V would be let's say we can write a log of some constant c. We can convert ln k into log of some constant c. Okay, then we can actually write, or better, let's have everything in log form only. You can always convert it, okay, by multiply and divide by 2.303. So let's say we have log p plus log v equals to log k. Okay, so from here we can write that log p can be equals to log k minus log v, or log p would be equals to log k plus log 1 by v. I hope you know the logarithmic functions. Even if you don't know, I'm just writing it over here, that log of v to the power minus 1 is minus log v, hence log to the minus log v would be v to the power minus 1. So we can write v to the power minus 1 as 1 upon v. So this is some appendix. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more gas laws, and we'll be starting off with Charlie's law. So we'll meet in the next lecture. Till then, good luck and goodbye.